create this partition primary index. Okay. So to understand this, we'll take an example of a table with two columns, order number and order date. Okay, so this is the table. There are two columns, order number and order date. This order number is the primary index. This is order number is the primary index in the table of two columns, order number and order date. So when order number is the primary index, a row hash value is generated correspondingly, which is responsible for distribution of the rows across the amps. So this is the row hash value. So the row hash value is responsible to identify in which amp the record has to be stored, right? So when I say row hash value, when I say row ID, everything is same, right? So row hash is a part of the row ID. When I say row ID is responsible for the row distribution, when I say row hash is responsible for the row distribution, same. Okay, so row hash we are considering here, which is responsible for distribution of the rows across all the amp evenly. So this row hash is also stored along with the data. Okay, so each and every row here is stored along with a row hash value, the primary index and the remaining columns. And it happens in all the amps. So the rows of this table distributed across all the amps here like this. And when you observe, after the distribution of the rows, within each amp, the rows are in the order of the row hash values. The distribution is as per the row hash values, and after the distribution within the amp, the rows are sorted in the order of the row hash values. You see 1, 3, 12, 14, 17. So it is in ascending order of the row hash values. There is no relation with these order number and order date. The rows are sorted in the order of the row hash values. This is what the arrangement is. When you create a primary index, okay, it generates the row hash value and it distributes the rows across all the amps as much as possible evenly. And after the distribution within the amp, all the records are sorted based on the row hash values. Okay, so now I'm trying to access the data from this table. If I access by using the primary index, that is order number, like that, select star from this order table where order number equal to so and so 1031, then how it would pick up this record? It generates the hash value for 1031 and it will identify in which amp it has been stored because it was already hashed while insertion. So it will directly jump to that particular amp, and within the amp, as this row hash values are sorted, it is easy for it to pick up the row and give the data. So it is a one amp operation, what we know, if we use a primary index. Okay. But now I have observed on this table the retrieval queries are like this. Most of the queries are with these range options on the date. Select all the columns from the table where order date between some range of the dates 2010-11-01 and 2010-11-30. So how much information I need here? 1 month of information I need here. Okay, in the 11th month of 2010, 01 to 30 means I want November month data of 2010. This is the retrieval query for this table. So to give this answer, what should happen internally here? Okay, so it has to set all the records which are belonging to 2010-11 in all the amp, right? So 2010-11 is existing here, is existing here, is existing here, It may exist anywhere because it is ordered by row hash value. It is not ordered by order date. So for order date, it has to search everything because it is a non-primary index column. So you are using it in the where clause. So you are going to see all the records in each AMP, and this operation should happen in all the AMPs. See, in this AMP, the records exist here and here. In this AMP exist here, here, all these brown colored records. So all AMPs would involve, and within each AMP, it has to scan the full table, right? So it has many tables. Each portion of table is stored in each AMP, that we know, right? So for this particular table, whatever portion this AMP has, that whole portion, it has to search to retrieve the data which belongs to this month 2010-11. Okay, so all AMP has to do the same thing. So all AMPs would involve, and within each AMP the full table is scanned for the data which is belonging to this date range. Okay, so it is a costly operation. Okay, if it is one time or two times this query executed, it's fine. Okay, we'll do a full table scan with an all AMP operation and we'll get the data back. If I find all the queries, almost 80% or 90% of the queries on the table are based on this range, the date range, because it is an order table. So everyone is interested to query this table based on the order date, like order date between so and so dates, or maybe the last quarter data, or maybe last 6 months of data, maybe last 1 year of data, last 1 month of data, maybe. Okay, whatever range it is, most of the queries are based on that particular order date. Then what we can do? Okay, so every time the 90% queries are doing all AMP operation and the to all table scan, that is full table scan, it is using many resources. Right? So is there any way that we can optimize the process of full table scan to avoid the resource consumption? Sorry. Okay. So now think this data is ordered based on the order date. How it would look like? You can see here. Instead of sorting the data based on the row hash values, if I start sorting the data based on the order date, what happens? All the records which are having same order date would come together. Right? All 10 nines would come together because it is sorted based on the order date, not based on any other column. And 10 10s come together, 10 11s come together, 10 12s come together. And this happens in all the AMPs. See, in this AMP also it happened. Okay, so the data in each AMP is sorted based on the order date, let's suppose. Then what happens? This particular portion of the data across all the AMPs would give you the data of 10 9. Okay. The data which is across all the AMPs at the same position, same blocks, would give you the data of 10 11. So now if I execute the same query, how I can retrieve the data back? In this AMP, it no need to search all the records. It just go to this partition and pick up the data which belongs to 2010-11. And if it extends within all the AMPs, it will get data from all the AMPs which belonging to the data, which belonging to the date 2010-11. So I no need to access the full table. Within each AMP, if I access that particular partition which belongs to that particular date, it is enough. Okay, so it is a all AMP operation. Yes, all AMPs involved in picking up their own portion of the partition. Okay, it is a all AMP operation, but it is not a full table scan. We are avoiding all other partitions from our scan. Okay, that is the advantage what we are getting with the partition. Okay, so if we use a partition, you are avoiding all other partitions from the scan. Are you doing all AMP operation? Yes, all AMPs are involved. But is it a full table scan? No, it is not a full table scan because each AMP required to access only its own partition. And we are avoiding all other partitions from the scan. Okay, so how we can get this data sorted based on the order date? By creation of a partition primary index on the order date. What is the primary index? Order number. That remains same. So the data distribution is based on order number. That also remains same. But what we are changing here, I am creating a partition primary index on the order date so that after the row distributions based on the primary index, within the AMP, the sorting of the data is done by order date, not by the row hash values of the primary index. That is only I am changing by creation of a partition primary index on the order date. What I am changing? Am I changing the distribution? No. The distribution is always based on the primary index. But what I am changing here? The sorting order of the data based on the order date. Within the AMPs, after distribution of the rows based on the primary index, within the AMP, if the rows are sorted based on the order date, it is easy for me to access this range dates queries. So I am creating a partition primary index. See how I can create a partition primary index. See this example. This is some different table, but it could be order table also. You see, after the primary index, this is the way how we can create a partition. Partition by range n is a keyword to specify what type of partition we have to create. There are two types of partitions. The range n is one partition, case n is another partition. We'll see that. So range n is one type of the partition, and within that the column on which you want to partition is a date column, and you give the range of the data that is between 2001 to 2010, 12, 31. So how many years of data I'm expecting in my table? From 2001 onwards till 2010, 12, 31. So 10 years of data I'm expecting, and this data should be partitioned with the interval of 1 month. Okay, so each 1 month of information is considered as a partition. This is the interval between each and every partition. So totally how many partitions I'm going to have with this definition of partition primary index on claim date? Anyone? Can you please calculate for me? How many number of partitions I'm going to have here?
120.
120 partitions, right? So I have 10 years of data. Each year has 12 months. So I'm totally going to have 120 partitions. For each year 12, I'm having 10 years of data. So it is 120 partitions. Good. So when I have 120 partitions, and my queries are accessing at a time only 1 month of data, let's suppose. Okay, so I will give the query such a way that range of the date in between 1 month, one last month. So how many partitions my query will access out of 120 partitions? Yeah. So when I have 120 partitions and when I query the data based on only last month, so how many partitions it will access?
Only one.
Only one partition. So how much of efficiency I am getting here in percentage?
Yes. Okay.
Almost 119 times. If I don't partition the table based on the date, if I give this same query of range, it has to do a full table scan. That means all the 10 years of data which exists on the particular ramp, it has to sit. But as I have partitioned it, it is enough for me to access only that particular month, right? So here we assume there are 120 partitions here, and so on, and you are accessing only one partition. You are avoiding 119 partitions from your search. So how many times this particular table is efficient in providing you the range dates? Almost 119 times. That is not a small thing, right? So 119 times you are improving your table by partitioning it based on the order date. Yeah, that is the advantage what you are going to get. Okay. So this is how.
Manohar, I have one question.
Yeah.
Here, while we are defining the partition, we got to know the min and max date that is available in that table data, right?
Yes.
Then only this is possible.
Yes.
So for future dates, we cannot predict this. Once the data is in, then we can go with the extension or expansion of this.
Yeah, good question. See, today, okay, in 2010 or in 2005, I am creating this table. I predict five years future, and I will create it. Okay, after these 5 years, means in 2010, what I have to do, whether I have to do a feasibility study, shall I increase this range, or is it enough for me at any point of time to have 10 years of data? Okay, so if at any point of time it is enough for me to have a 10 years of data, then what I will do, I will increase this to 2002 and I will increase this to 2011 something. Okay, and I have to archive the data of 2001 into my tapes, okay, and I will keep on adding 2011 data. So we can alter the partitions whenever this partition range is fulfilled with the maximum value. You can alter this partition, okay, and before the alteration you pull all the data of 2001 up to 1231. The 2001 1231 data you just pull out of this table, keep it in your backup tables or tapes, and then you alter this partition in order to have the future dates again. So at any point of time, if your requirement is to have 10 years of data, then you keep on altering the partition, okay, and remove and archive the old partition data. So like this, it is called as rotate partitions. Okay, so this is circular rotate partition where you will have at a time 10 years of data.
Hey Manohar, with the partition primary index, do we use this partition primary index with the stored procedure by any means?
Store procedure is the way of execution of the sequence, right? Yes, you may execute it. Yeah.
Okay.
So,
or like a macro we use this one, like.
You mean accessing the data was saying, or creation of the table was?
Not creation of the table, like accessing the data as well as creating.
Yes, accessing the tables, yes, you can do through macros. Because in macro there is a limitation that you can have only one DDL statement, that too at the end of the macro. There is a limitation in macro, so that's where I asked you. Okay, if you are accessing the table, yes, whatever you can do through BTQ, through SQL Assistant, the same thing you can do through macro also, if it is accessing of the data based on the partition. Yes.
Okay, in macro you can only put one DDL, right? I mean, you can put this one in the macro, right? Create table claim, you can put in the macro. Okay. I didn't understand the 120 times, 119 times it become more efficient.
Okay.
This one is like, I understand, like it's query the data from 2001 2010, so it's like 10 years almost, and it's like 1 month, so it's like 120 months of data it's pulling, right? But you said 119 times is faster, so it's like, what is the original table like? What like?
See here you understand how many partitions we have here. 1, 2, 3, 4 partitions.
4 partitions. Yeah.
And when I'm accessing only 1 month of data here.
Oh, 1 month of data. Okay. Okay. Now I
So,
understand. Yeah.
yeah. So how many times I'm getting efficiency?
Okay.
For
Yeah,
almost
that I
3
understand.
times, right? So instead of accessing all these
Yeah.
4 partitions, I'm accessing only 1 partition. So 3 times it is better. In same way, if you have 120 partitions and we are accessing only 1 partition, it is 119 times of better.
I see. Okay. Got it. Thank you.
Manoj, would it be right to say that partition primary index does not impact the distribution of data across the AMPs, but just sorting within the AMP?
Yes, because the primary index will remain same, so the data distribution will remain same, but after the distribution within the AMP, the order of the data is changed based on the partitioned column. And Radhika, did I answer your question? I think it was interrupted.
Yeah,
Okay.
I got it. Like that's the question. Like when we were coming up with the partition criteria, we got to know the range, and based on that, you're saying we got to either increase and
Yeah.
move the data to archival tables.
Yes, exactly. So by the time you have some future data, and once it is fulfilled, then you have an option of altering it, or now in from Teradata 12 onwards you have multi-level partition primary indexes also, MLPPI. This is called as PPI. We have MLPPI, multi-level partition primary index. So within this there is one more column what you want to order on. You can use that particular column also within this range, so that once order dates are same, within these rows there is one more column which decides the order again. Like that you can have a multi-level partition primary index. That is a new concept which is in Teradata 12 onwards. Okay, and here you see one more type of partition primary index, that is called as case n expression. Okay, partition by case n. Okay, so you can see the example. The claim amount is less than 100. The rows which are having the claim amount is less than 100 would come under one partition. Whenever the claim amount is less than 1000 and greater than 100, those rows will come under one partition. These range queries greater than 1000, less than 10,000 would come under one partition. Okay, like this, based on case expression also you can decide what all rows should go into what all partitions. So how many partitions I have defined here? 1 partition, 2 partition, 3rd partition. 3 partitions I have defined. And there are 2 default partitions what you can use along with your defined partitions. What are those? Those are called as no case. That means there is any row which has claim amount not falling under any of these ranges. That means, let's suppose the claim amount is 12,000. Would it come under any of the partitions? Can you be mute please if you are not talking? Okay, so if the claim amount is greater than 12,000, would it come under any of these defined partitions? No, right? So where this row has to go? If I don't define this no case, you will get an error saying partition violation. Okay, so if I define this no case partition along with the partition definition, whatever rows which are not falling under any of the defined partitions, those rows will go into the no case partition. Okay, so we can avoid the errors while loading the data based on partition violations by having a no case partition defined. Similarly, there is one more. Yeah.
On an AMP, is the equivalent space kept for each partition?
Pardon?
On a particular AMP, is an equivalent space given to each partition?
I'll come to that. I'll come to the spaces part.
Okay.
Okay. So no case is to accommodate the data which doesn't fall under any of the defined cases. And how about this unknown? There is one more default partition which is an unknown. What it does, if there exists a null value in the claim amount, the partitioned column, then those rows which are having null values will fall under this partition unknown. Okay, so these are the two default keywords to give you default partitions where they can accommodate the data exists but it doesn't fall under any of the defined partitions. And this unknown is if it has a null value. Okay. And if the claim amount here itself it is mentioned as a not null, then you no need to mention a unknown partition, because this unknown partition is to accommodate null values in the claim amounts, right? So if the column itself is defined as a not null, you no need to use this unknown. But if it is nullable, then better you have an unknown partition also. So this is the best practice. You use these default partitions while creation of the partition primary index so that you can avoid errors which come for partition violations. Okay, so once they are accommodated, then you will see and analyze, are there any rows in this no case partition? So if they are coming, is it really a valid data or not? If it is really valid data, then alter your partition primary index to define one more new range. Okay, so that validation should happen at the application level as developer or as a support person or support DBS. You may do all this analysis, but in a regular run, in a regular batch job runs, yeah, how many errors you can avoid? Possibly we will try to avoid all those errors, right? So here, instead of failing our job because of having other partition or other than the defined partition data, you better capture it in the no case partition and then analyze it later. And similarly, here also in range, we have a no range or unknown. You better you use those no range or unknown in order to accommodate the data which is not defined as a partition here. Okay, so in this, if I get a 2011 data, I will get an error. So instead of that, if I use a no range default partition, it will go into that no range partition. Okay.
Hey, Manoj,
Yeah.
can we actually have a partition, a primary index, what is called, yeah, can we have a partition on a primary index, the same column, or is it possible or not?
Yes, it is possible. Okay, you can have
Okay.
partition primary index on the primary index also, but provided it should not be a unique primary index. Why?
Oh,
Can you answer me? Why it should not be a unique primary index?
so there's no point of partition if it's
Yeah.
a unique primary index.
Right? Everyone got it? Good question. Okay, so I can create.
Manohar, I have one question. Like, is this no case?
I think we lost you. Okay, so what I'm saying here, we can have the partitions defined on the primary index also. So what happens? The distribution is already happened, and the sorting order is also based on the values of the primary index, but provided you should not have a unique primary index, because it is to make the values get together when you have a same claim ID, right? If you define a partition primary index here. If it is a unique primary index and you have only one row with the same value, then no point of making all the records together. So we'll have only one record in each partition, then it will degrade your performance. So you are creating those many number of partitions for unique records. Okay, so it is again a degrade performance. That's why it won't allow you to create the partitions on the unique primary index. Okay.
So the basic purpose of this is to avoid full table scan, right? You are
Yes.
still looking at different AMs, AMPs, but you are looking at some specific values, right?
Yeah.
Those
So the
AMPs,
main
they follow
advantage
that.
is partition elimination. Okay. So in the 10 years of data, anyone is interested to access only maximum of 6 months of data, 1 year of data, right? all 10 years of data we generally don't access. It is stored there for audit purpose. Fed audit says banks has to store 12 years of data at any point of time. So that's where, okay, in order to comply with the Fed rules, they may be storing the data, but most of the users may not use all the 12 years of data for their reporting in most cases. Okay, so they access only last quarter data, last 6 months data, or last 2 years data, 3 years data max. So to avoid all those other partitions which are stored in the table, if you partition it, you can obtain the advantage of partition elimination once you partition the table. That is the main advantage. Okay. So now let's see what are the advantages.
Manoj, can we alter the partition index?
Yes, you can alter the partition.
Yes.
Yes, you can alter table and partition the range or partition the intervals, whatever you want. Yeah, but ensure the new partitions what you are doing, they should not come under partition violations. Otherwise, alter is not possible.
Okay.
If I already have the 2001 data, and if you are changing your partition range from 2001 to 2002, then what happens to this data, which already exists in the table? So it won't allow you. Partition violation would occur. So please take this out and then alter it. Okay.
Yes. So just one more. So if the data is not like, if it extends beyond the table, right? Like as you mentioned, right? So it will not return anything, right? It will like like what it will return then? Let's say like the program is not fine. Check your return error.
Correct? I didn't get you.
Yeah, if the data is out of range, right? Like one of the values, the date values are within the range, right? That's there in the table, and the other one goes beyond the range, like 2020 or something like that. So it's there up from 2001 to 2010, but somebody is training till 2020 in that partition. So in that case, it will return and sort of it will return a table value, or it will return any value, or
it will throw an error. It will throw an error, partition violation. It cannot accommodate the 2012 data as you have mentioned the maximum range as 2010. So what I can do to accommodate those records, I have to use the no range partition while defining, similar like this.
Okay. If I use no range, then it will still throw an error?
No, it don't throw an error. It will accommodate the rows which are not in the defined partition into the no range partition, so that you can analyze the data later after the insertion. It won't throw an error. It will go into the no range partitions. If you define it. If you don't define, yes, you will get an error. Partition violation.
Okay.
Okay, so it is not mandatory to define
so
this
partition by
partition.
no range would be okay. Now, say a partition by using no range would be very much similar by using I mean it would be very much similar that in the case if you are not using PPI, isn't it? Because it will be a full table scan.
See, whatever data coming under these partitions, they are partitioned. But if it is coming out of this range, only that data will have another partition appended to it called as no range. Right?
But Ram, if I, as I've said, right, so if you are querying which is out of range, so at that point of time nothing will come, right? Everything will come in a no range then.
Yeah, if you are giving a range of the dates which is not in these partitions, then it will pick up the data from the no range partitions.
No range, okay.
If it is there. Okay. Any other questions?
Yeah. You mentioned that we can drop and alter and create the partition primary index using an alter statement.
Yes.
So can we change the interval as well?
Yes.
Okay. Okay. In that case, like it's going to do a repartitioning, or?
Yeah, the ordering will be changed.
Okay.
When you drop this partition, when you create partition on other table, so within these rows of the AM, it will change the order of the data.
So whatever the statement would be like how would like drop partition, drop primary index on C QID,
Yes.
and then
Alter
you put
table,
like
drop partition,
alter table.
or alter table, modify partition, like that.
And also one question: can we have a primary index on 2 columns, or more than 1 column?
You mean partition primary index on a combination of columns? Yes, we can have.
Okay. Okay.
But doesn't make sense in most of the cases.
Yeah, it will complicate it. I mean, I don't know if only the data is some type it will be useful.
Yeah. Okay. So shall we forward?
Yeah. Yeah.
Or do you want to research more on this?
No. Fast forward.
Okay. Fine. Okay. So now let's see what are the advantages. So here these advantages of the PPI and the advantages over other RDBMS also are mentioned here. So the partition expression definition is the only thing that we need to do in Teradata in order to create the partitions. Okay. But in other RDBMS, when you want to do this partition, you have to manage the space which is required to accommodate these partition blocks. But here, no separate partitions layouts or no disk layouts are required. Okay. That means if you consider a partition, the last record and the first record of the partition would exist in the same data blocks. It will maintain internally. So no redefinitions, no movement of the spaces from one partition to other partitions. All these things are not required in Teradata partitioning layouts. So in other RDBMS, we have to do some overhead on the definition of the spaces for each partition and moving the spaces. All those things are not required in Teradata. So even the data distribution is also not impacted. The data distribution is on primary index only. So even you create a partition primary index, it won't impact the normal data distribution. And after creation of the partition primary index, you no need to change any of the existing SQLs on the table. The already existing queries would run fine. The only thing is the way of execution of the query will be changed, but the query what you use would be same. So here if you observe, we use the same query to access data from the table which is not partition and from the table which is partition. The query is same, but the way of execution is changed. Okay, so the users, for users it is transparent. And whatever you are doing on the partitions, that is not required to know by the business users, but they will realize the efficiency of the queries. So these are the advantages of partition primary index in Teradata. And what are the disadvantages? We will see disadvantages also. The first disadvantage is it occupies more space than a normal table, because along with each and every row it would store a partition number also. So it is the row hash. So here you see only row hash, but here the row ID contains the partition number also on each and every row, which is of 2 bytes. What is the size of row ID? Anyone? You remember what is the size of row ID? 32 bit?
64 bytes? 64 bit, Manohar.
Right? 64 bit. Because row ID is the combination of row hash value plus uniqueness value, whereas row hash is 32 bit and uniqueness value is 32 bit. So row ID is 64 bit. So along with the 64 bit, it has to add a partition number of 2 bytes. Okay, so each and every row is 2 bytes long. Let me show 2 bytes. Okay, so every row is added with 2 bytes longer value, which is called as partition number. Okay, so the pump space needed to store this table is more. In terms of space, it is a overhead. That is 2 bytes longer for each and every row. And then if you have queries on the table which are more on the primary index, then the primary index access may be degraded on the partitioned table. Here you have partition list on based on order date, it's fine, and you are accessing the data based on the partition column, it is working fine. But how about the query which is based on the primary index? Would it execute with the same efficiency how it was with the non-partition? Yeah, so here if I write a query select star from order where order number equal to 1026, it is a 1 AMP operation and it is very easy to pick up because the data is sorted based on the row hash values of the primary index. But here the order is not based on the row hash values. Yes, it is 1 AMP operation, no doubt in it, because we are using the order number in the where clause and order number is the primary index, so it can find out in which AMP this data exists, but after coming to this AMP it cannot find where this order number exists, so it has to do a full table scan. So all the partitions it has to verify to find out the data based on the primary index because the order is changed from row hash to order date. So the queries which are based on the primary index are degraded. And then if you join two tables, in one table it is partitioned and in another table is not partitioned. Okay, when you are joining these two tables, then again the join performance will be degraded. Okay. So
Manu, can you go over this one, like last 2 points? You said like one of the things.
Yeah, let me repeat. I'm not completed. I'm about to complete it again. Okay. So the what I'm trying to say, if you have the primary index and when you decided to create a partition primary index on the table, you have to analyze how many queries are using the primary index of the table. Let's suppose if 50% of the queries on the primary index, okay, and 30% are on the partition primary index. That's what I mean. You are supposed to create a partition primary index. You are thinking to create a partition primary index. Then do you decide to create a partition primary index or not? Okay, 50%, more than 50% is accessing through the primary index, and you are thinking to create a partition primary index on the date columns. So what is your decision? Are you going to create it or not?
More than 50% is on with the primary index, right?
Yeah.
Then no news. No news.
You can get a secondary index, right, instead of a partition. I don't know.
Yeah. But my question is, are you going to create a partition index or not?
No.
No.
Right?
It's more than 50 makes sense, right? More
Yes.
than 50.
Yes. So it is all, I mean, all your feasibility study again, how this table is being used in the reports or in the other ETL queries. If most of the queries are based on this partition column, yes, you go and create this. If most of the queries are using the primary index itself, then you know you don't create a partition primary index. Okay, so it is getting the benefit when you use that partition primary index as a range or case. But if the usage is less percentage than the primary index, you don't create because the primary index access will be degraded because the sorting order is changed from the row hash value to order date. So whenever you access the primary index, it has to set all the partitions for these values within the AMP. So it is a single AMP operation, but within the AMP operation it is a full table scan. So you are degrading the primary index based queries by creation of a partition primary index. And if it is a join, you can assume okay, how many times it will be degraded than the non-partition table. Okay, when we have two tables and two tables are not partitioned and they are joined based on the primary indexes, it is the best join. Right? Both are hashed on the primary indexes and this join is also based on the primary index, so it runs fine. But if one of the table is partitioned, then the join performance will also be degraded because in one table it is partitioned, in one table it is not partitioned, so the order of the data is changed So it has to set all the records in one table, which is partition for each M. So that joins also will be degraded. So we have to do an analysis how we are going to access this table. Is it mainly on the partition index or the primary index? Then you decide whether it is good to have a partition primary index on this table or not. Clear? Any questions?
Manohar, one question actually. We have a PPI, partition primary index on a table, and we are trying to query a data through a primary index. Now, you mentioned that it was going to be a one EMP operation, but like a full table scan.
Full table scan within that AMP. Within that AMP.
Within that AMP, okay. That's what I want to clarify.
Yeah. That means within that AMP, it has to set all the portion of the table data. That's what that means.
Hey, Manohar, I have one question.
Yeah.
Manohar, let's say on a table, my primary index is on the date column itself, but I also have lot of queries to run on the range. So can the same primary index be also partitioned?
Yes, yes. So the order of the data would also be on the value of the order date. So it is as much as the non-value. I mean, yeah, you are distributing the rows based on the order date, and you are ordering the data also based on the order date value instead of the row hash values.
Okay.
Because that also improves the range only. If you have a equi condition on the date, then it won't know. Okay, so within that partition, it has to set all the rows again, right? If it is an equi condition with this single date, something.
Okay. Manohar, you brought a very good point. Like if it's an equi condition with a single date, what's going to happen? And if you have a partition index on that column, if somebody is asking only for a specific.
That's what I'm explaining, right? So if I have this order date as the primary index, and I have partitioned also on the order date, the sorting order is based on the value of the order dates, but not the value of the row hash. So we have the same format, and if you are using an equi condition with 2010-11, then you will come and pick up this data. Okay, but within this,
how efficient it is?
Efficiency will be better here itself if it is an equi condition. If it is not a range condition, if it is an equi, then here it is good, because the primary index and the order is based on the primary index. So it is good that it will pick up the data from the AMP without the ordering. And here the disadvantage, so I mean most probably both are same, right? So the primary index is same, the partition primary index is also same. When you give the 10-11, it is picking up only this partition. You are not giving the range, but you are giving where date equal to 2010 and 11, and you have to extract month also anyway, because here it is the date. So you have to extract month and you have to give it, and then.
This is the situation when both the columns, they have the same the primary index and the
partition
primary index are in the same column, right? That's what you're telling me.
That's what the question was. So when we have the primary key and partition primary index key on the same column, what happens? This is almost same what performance we are going to get, but the overhead of having partition numbers, that is the overhead.
Okay.
So better
and
you go for
Manohar, what would happen if somebody is querying both the columns are different? I mean, the primary index and the partition primary index columns are different, and somebody is putting an equi condition on a partition primary index instead of a range or a case equi condition. So in that case, what would happen?
If it's an equi condition on partition primary index.
Yeah, and the partition primary index is not the same as the primary index. There's two different columns are there.
Yeah, you tell me what happens. If I partition the table like this, and if I am using a order date equal to 2010-11-10, then tell me what happens here.
Well, the data should be fetched, yes. But it will, I think it will degrade the performance, right? Because it's like, I don't know, this looks to me degrade the performance of that partition.
Pardon?
It will take data directly from that partition 2010.
it will increase the performance.
Yeah, if it is order date, is order date equal to 2010, 11, 30, I'm doing. That's what we are saying, right? So I'm giving equal condition with the order date. Okay, so anyway, the order date is not the primary index, so it is not a single amp operation. So all the amps has to be involved, and within this, the sorting order is based on order date, so it can pick up that partition and give you the data. But within the partition, it has to search all the rows because you are equating with a single date. You are not asking all the date of this month. So within this partition, it has to search the data.
So
it will be a all amp. It will be an all amp operation, but not a full table scan, though.
Yes. Yes.
Right.
Yes.
Okay.
Because you are using the partition column in the equal condition. So within the partition,
it
will search the records.
Scanning within the partition.
Yep.
Yeah. Manohar, one question actually, like if, like since people are asking about the equi, like if instead of a range we have a equi date. So what if we do a order number and order date as one primary index as a composite field? I mean, will that increase, do anything?
No. If you use that order number and order date both in all the queries, then it will improve the primary index access. Otherwise, it will degrade again.
Thanks, Manohar.
Okay.
So Manohar, the question, the answer would be it would degrade the performance, right?
Yes, it would degrade because see, if you use all these composite keys of primary index in your retrieval queries, then only you will get a 1 amp operation, isn't it? So if there is a need that as order number and order date you are going to use, that's fine. But if you see order number is unique almost, so why you use an order date there? As per business, we generally don't use a combination of order number and order date. So if you create a primary index based on order number and order date as a combination, you have to use that order date also in order to get 1 amp operation. Otherwise, you are not going to get 1 amp operation. So that's where you are degrading your queries.
So if you have an equicondition on the primary index, and not the primary index, the primary partition index, it degrades the performance.
Yeah. Okay.
And this partition primary index is made by the DBA, right? Not.
No, you can also test it. I mean, if you are a developer, like you can test the performance. Okay, if you create the partition primary index, how the reports are being accessed, how the SQL is being executed. You see the explain plan. You see the spool space. You see the time taken to execute this query. If it is working fine and you see all the queries are based on this, you can propose it so that DBA will also create it in the implementation, like in the upper environments like production or UAT. But you have to give actual details what the benefit you are going to get by creation of the partition primary index by testing it in developments. Okay. So coming to the holidays, we have everyone, right? I hope no one has dropped. So coming to holidays, how many are going for vacation on this 22nd and coming back again on 25th? That means India time 23 to 26. Can you ping me yes in the chat window so that I can see how many are there and you can decide as well. Those who are going on vacation in these dates, please ping me yes in the chat window. One, two, only one time, everyone, right? 3, 4, only 4. Okay.
It will be like 22nd actually, right? So
yeah, 22nd US time. I am saying 23.
Oh,
India,
okay.
India time. So almost 6 to 7 people. Okay. So what we'll do, then you have to agree we'll have 1.5 hour sessions from tomorrow onwards. Is that fine?
Yeah,
Each session,
fine for me.
1.5 hours till 22nd. And again, this Saturday I am out, so 17th and 18th also you can plan something if you have. So 17th also I am holiday, India time. All India time I am talking about. I don't want to confuse you all. So India time 17th. I'll be giving off. So you can plan something.
Manohar, 1.5 hours is a problem for me. Actually, I need to leave the office by.
It's not possible for 9:30 till 9:30.
It's not possible actually because I will have a call by 9:45 around 10. So every day.
Yeah. How about 7:30 to 9?
That is fine. 7:30 to 9 is fine.
Is it fine, everyone? 7:30 to 9?
Not for me.
I'm fine.
Okay. Fine then. We'll meet at 8 o'clock and we'll see. Maybe 10 minutes or 15 minutes we'll go forward and we'll try to complete. Otherwise, what happens is we have to take one more 4 days or 5 days extra than the actual completion because of these holidays and all.
I have a problem only just till this next week, like otherwise I can start early.
Pardon?
You said you want to take earlier, right?
Yeah.
Yeah, it's just this week I can't do that, you know. After that, eventually we can take some extra, you know.
Means 19, 20, 21.
Yeah, because you know my classes are already overlapping, and if you start even earlier, I completely miss that class then.
Okay. Fine then. Let's come as usual. 8 to maybe 10 minutes. Yeah, I may extend. And we'll see. Maybe 3 to 4 sessions will be increased than the expected. That would be fine for everyone, right?
Yeah, it's fine.
Yeah. Okay then. Yeah. Thank you, everyone.
Hey, Manohar, actually I got disconnected for 10-15 minutes while you were discussing the advantages of PPI. So can you, if you can quickly go through it, or if you have recorded it, if you can share this with me.